Today we will solve the problem 2.36 of Griffith fourth edition Introduction to Electrodynamics. The problem 2.36 is consider two concentric spherical cell of radii A and P. Suppose the inner one carries a charge Q and outer one a charge minus Q. Both of them are uniformly distributed over the surface. Calculate energy of this configuration using equation 2.45 and using equation 2.47 and the result of equation example 2.9. First we will solve the part A, that is using equation 2.45. So equation 2.45 is this one. This is equation 2.45. Then about this configuration, we have two spherical cell. One is radius A and other one outer radius is P. This is P. And the inside you have charge Q inside this. Outside it is minus Q. Uh, Now you have to use this formula to find the energy. That is W is equal to epsilon naught over 2 integral between A to P. So you consider a Gaussian surface inside between A and P. Between A and B, it is enclosed by the charge plus Q. Remember that, and radius A. So we are taking the point under consideration at a distance r from the origin, at some random distance r. So now from this formula, energy is equal to epsilon naught divided by 2 A to P integral E squared T tau. Now inside the inner sphere, inside the inner circle, there is no, if you select the Gaussian surface, the total charge will be 0. No charge inside the spherical cell. And outer cell, you have Q plus Q minus Q, outer cell also 0. So charge will be available between A to P. So then the E squared, electric field squared, E is equal to Q divided by 4 pi epsilon naught R squared, R cat along R direction. This E squared, so I am taking E squared, that is Q divided by 4 pi epsilon naught R squared whole squared, and T tau is 4 pi R squared T R. Here you can see, here you have 4 pi R squared, also here you have epsilon naught. So this 4 pi epsilon naught R squared will cancel once. This square will become 4 pi epsilon naught R square only. So now you take this Q, except R square, you take other thing outside because the integral is between the R with respect to R. So this will get cancelled naturally, and this epsilon also will get cancelled. You will have Q squared divided by 4 epsilon naught R squared, because 4 pi R squared is cancelled already. So 2 into 4 you will get 8 pi epsilon naught. 1 over R squared I brought inside the integral. If you integrate 1 over R squared, you will get minus 1 over R. So you see the limit A to P. If you change the limit, then you can change the sign of this thing. You change it to P to A. Then this negative sign will become positive, 1 over R. If you apply the upper limit, now upper limit is A. So 1 over A, and you apply the lower limit, that is minus 1 over P. So the energy is equal to Q squared divided by 8 pi epsilon naught multiplied by 1 over A minus 1 over P. Now we will move on to part P. Now the second problem is we have to use the equation 2.47. This is equation 2.47. The total energy is equal to energy due to sphere 1 and energy due to sphere 2 plus epsilon naught integral from p to infinite e1 dot e2 t tau. Where we have seen in part A, energy is equal to epsilon naught over 2 integrating between E squared with respect to tau, t tau. Now, unlike the charge and electric field, this energy is not you cannot apply superposition principle for energy. You can apply superposition principle only for the charge and electric field, but here you are calculating energy. Then naturally one interaction term comes, W1 plus W2. This is interaction term. Now you have to calculate this. Here it is quadratic. What I mean by quadratic is, see, you have epsilon naught divided by 2. Here this will become E1 squared, integral E1 squared plus integral E2 squared and integral E1 E2. 2 E1 E2 is supposed to come. So here you can see epsilon naught divided by 2. Here only epsilon naught. So we are taking it, we are applying quadraticness. So a plus b whole squared is equal to a squared plus b squared plus 2ab. This last two term is 2ab. Last term, third term is 2ab. That is, if you multiply 2 times a and b, you will get epsilon naught. These 2 will get cancelled, e1, e2. So now we have to find this term, which is equal to epsilon naught p integral from p to infinite e1 dot e2 t tau. Here y p1, see, we have two circle concentric sphere, sorry. So outer radius is p. So only after p, this will be, both will be in the same direction. Otherwise the direction is will be different. So naturally this dot product exists only when r is greater than p. So we have imposed that minimum is p and maximum infinite. So e1 dot e2 is equal to e1 is q divided by 4 pi epsilon naught r squared, and e2 outer sphere is charged by minus q. So this is minus q divided by 4 pi epsilon naught r squared. T tau I am replacing 4 pi r squared dr. Now you can see this epsilon, this epsilon and this 4 pi r squared will cancel with this one of this 4 pi r epsilon naught r squared. So only this 1 4 pi epsilon naught r squared left. Here q into minus q, you will get minus q squared, and this is 4 epsilon naught. I am taking 1 over r squared inside. We are integrating with respect to r. So if we integrate 1 over r squared, you will get minus 1 over r. So this will become this minus, you have to apply here the upper limit and lower limit. Upper limit is this will become 1 over r, that is 1 over infinite minus 1 over p. Lower limit is p. So this is 0. This will be 0. So the minus of minus will become plus. So simply you will get 1 over p. But already you have minus q squared. So this can be written as minus q squared divided by 4 pi epsilon naught p. Now W1 is q squared divided by 8 pi squared. From the part 1 we have seen that it is q square divided by 8 pi epsilon naught 1 over a. Similarly, for W2, it is 1 over p. And here I want to bring the denominator as a common one. So you multiply and divide by 2. This will become 2q square divided by 8 pi epsilon naught 1 over p. So now you take q squared 8 pi epsilon naught as a common outside. Then you will get 1 over a here and 1 over p. Here minus 2 over p. Minus 2 over p. Then if you add these two terms, 1 over p minus 2 over p, you will get minus 1 over p. This is minus 1 over p. So this will become the total energy is q squared divided by 8 pi squared 1 over a minus 1 over p. Exactly what we got from the part A. Both results are the same. Thank you very much for watching my video continuously and supporting me. Thank you very much.